All right, this time we're talking about word problems, everybody's favorite. These, fortunately, are real easy mathematically because you don't really have to do any of the math. You just have to understand what the question's asking you about. So let's take a look at this. Fantastically wordy problem, pretty typical for this section. The amount and quality of milk produced increases when dairy cows are fed high quality alfalfa. Although annual milk consumption per capita in China has been on one of the lowest in the world, it's increased greatly in recent years. Consequently, the demand for blah, blah, blah. In 2008, approximately 20,000 tons of alfalfa were imported. The number increased approximately 650,000 by 2013. Okay, that's the only information we really need so far. Source, blah, blah, blah. From there down to there is citing the source. The increase in imported U.S. alfalfa can be modeled by the exponential function. That's what you really care about. That's the function that gives you the amount of alfalfa when you put in x, which is the number of years after 2008. So that's all you need to do with this function is put in the number of years since 2008, and out will come the tons of alfalfa. It says right there. So the question that they ask us here is how much will be imported in 2012 and 2016? Well, 2012 is 4 years after 2008. So all you have to do is plug those numbers into the calculator. So it'll be 22611.008 times 1.992 to the power of 4 for 4 years, and there you go, 356,022. Pretty easy stuff. Let's look at the next one. This one's different in a couple ways. Salvage value. A restaurant purchased a 72-inch range with 6 burners for $6,982. The value of the range is 85% each year of the value the preceding year. So it's getting less and less valuable every year, loses about 15% of its value. After T years, the value is given by the function v of t equals 6,982 times 0.85 to the t power, very much like our compound interest problem, just set up a little bit differently. And whereas to graph the function, find the value after 1, 2, 5, and 8 years, and the restaurant decides to replace the range when its value has decreased to $1,000. After how long will the range be replaced? So we get 3 parts. Most important thing is to understand the problem and set this up. So go to the calculator, and we're going to put it in for y1. It's 6,982 times 0.85 to the x power. And of course, if you go to graph it, there will be no graph there because our numbers in the real world don't usually fall between -10 and +10. So we need to set up our window. And this is the same as the several times we've done this already in class. Our x min will always be 0. Our y min will also always be 0. We just need to figure out the x max and the y max. Now, we know that x stands for number of years that we've had this range. And in the problem, we're asked to find the value after 0, 1, 2, 5, and 8 years. So we know that x needs to go at least to 8. And we can see, because I've got the teacher's edition here, that we know the answer to the last part of the problem is 12. So we want to go out at least that far. So since we're talking about years, we have a stove. It wouldn't seem unlikely to maybe hang on to it for 20 years. So we'll put 20 in for the max. Now the y max here is easy, because this function is going to be decreasing. We know where the value starts. It starts at just under $7,000, and it goes down from there. So if we start with our max at 7,000, we should see the curve start and then fall. So we've graphed the function. We want to find the value after 0, 1, 2, 5, and 8 years. That's really easy. If we know a year and we want the value, that's a trace problem. So we will go to trace, And then we can put in whatever value we want. Here, let me zoom back out a little bit. If we want to know the value after 0 years, put in 0. And it'll tell us $6,982. After 1 year, $5,934.70. After 5 years, 8 years, etc., we just need to put in the year, and it will give us the value after that many years. So that part's easy. The third part is also not terribly difficult. We were asked, when is the value of this stove going to drop to $1,000? That's when we're going to replace it. So when is it going to reach something? Well, if I go into Y2 and I put a horizontal line in at 1,000, I'll see exactly when that crosses. And we can find the exact point where that crosses by doing second calc 5, enter, 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 just as we have all semester. And we get 11.957. So after just about 12 years, we're going to replace the whatever the heck this was we were talking about, a 72-inch range. And that's all there is to these word problems. Figure them out, put them in the calculator, set up the window if necessary, just like we've done with linear and quadratic functions all semester. Next time.